Okay, fine. So using this first row here, we are going to evaluate the determinants. So I'm going to start with 6 minus lambda, delete the row and column in which 6 minus lambda lies in. Then I'm going to have this equation minus this. So this equation right here will be 9 minus 6 lambda plus lambda squared minus 1. Okay, plus 2 because this position comes with a minus. Delete the row and column in which this lies in. Then this will give me minus 6 minus 6 plus 2 lambda. Then minus that will be plus 2. Plus 2. Then finally, plus 2, the last position, delete the row and column in which this lies in. Then that will give, so this and this will give 2 minus, this and this will give minus 6. And then minus 2 lambda, that will give plus 2 lambda. And this is supposed to be equal to 0. Okay, fine. So let's open this up with 6 and then open with minus lambda. So opening up with 6, we will have, so 6 times 9, that will give us 54, and then minus 36 lambda, plus 6 lambda squared, minus 6, and then opening with minus lambda, we will have minus 9 lambda, and then minus will give us plus 6 lambda squared, and then minus lambda cubed plus lambda. Now onto this bracket, minus 6 plus 2 will give me minus 4. So minus 4 times 2 will give, minus 4 times 2 will give minus 8. And then 2 times 2 lambda will give plus 4 lambda. Then finally this bracket here, so plus this right here is supposed to be 2. It looks like a Z, but it is actually 2. So we have 2 minus 6 will give minus 4. Minus 4 multiplied with 2 will be minus 8. And then 2 times 2 lambda will be plus 4 lambda. This is equal to 0. Okay, fine. So let's put that together. Let's take the like terms. So I'm going to start off. So I'm going to start off with taking the value of minus lambda. So minus lambda cubed, and then take all the values that have lambda squared. So this is 6 lambda squared plus 6 lambda squared. So that will be plus 12 lambda squared. And then take off the value that have lambda. So minus 36 lambda minus 9 lambda. So that will give minus 45 lambda, minus 45 lambda, which other value with lambda over here. So minus 45 plus 1, that will be minus 44, minus 44 plus 4, that will be minus 40, minus 40 plus another 4, that will be minus 36 lambda. So minus 36 lambda. And then finally the constants, 54 minus 6, that will give 48, 48 minus 8, that will give 40, 40 minus another 8, that will give 32. So plus 32 is equal to 0. So we can decide to negate the whole equation so that this one here, which has the highest value of lambda, is positive. So this is lambda cubed minus 12 lambda squared plus 36 lambda minus 32 is equal to 0. So we are going to use the trial and error method or functional notation method. So we're just going to take random values of lambda and see if they satisfy the equation. And then after we get at least one which satisfies the equation, then we can be able to get the other one. So let's take lambda is equal to 0. For lambda is equal to 0, if we replace here, we'll have 0, 0, 0. We will have minus 32. So this does not satisfy. Let's take lambda is equal to 1. For lambda is equal to 1, we will have, let's write that down, 1 minus 12 plus 36 minus 32. And what does this give? 1 minus 12, that is Okay, 36 minus 32, that will give 4. So 4 plus 1, 5, 5 minus 12, that will obviously not give a 0. Okay, let's try lambda is equal to 2. For lambda is equal to 2, let's replace. So 2 cubed, that will be 8 minus 12, 2 squared, that is 4. So 4 times 12, that is 48. And then plus 36 times 2, that is 72. Minus 32. So what does this give? 8 minus 48 will give minus 40. Minus 40 minus 32 will give 72, and this will give 0. So lambda is equal to 2 is one of the factors, of this equation. So if lambda is equal to 2 is one of the factors, so basically lambda minus 2 is equal to 0. So we'll take that and then divide it by this and get to know the rest of the factors. So lambda minus 2, and then we are going to have lambda cubed minus 12 lambda squared plus 36 lambda minus 32. Okay, so carry out long division to get lambda cubed here. Take lambda squared, so multiplying this by this, we will have lambda cubed. This by this, we will have minus 2 lambda squared. So what does that give? This will give 0 here, minus 12 plus 2, that will give minus 10 lambda squared. Bring this down, so we'll have plus 36 lambda. To get minus 10 lambda squared, so we'll have minus 10 lambda there. If you multiply with this, it will give you minus 10 lambda squared. So here we'll have minus 10 lambda squared, and then multiplying it with this other one. So this and this will have minus will be plus 20 lambda. So what does this give? This subtract will give 0. 36 minus 20 will give 16 lambda. Drop this down, minus 32. To get 16 lambda, so we will multiply this by plus 16. 16 with this will give us 16 lambda. 16 with this other one will give us minus 32. So subtracting that, we get 0, 0. So lambda minus 2 multiplied with lambda squared minus 10 lambda plus 16. This gives us this particular equation and is equal to 0. Since we already know lambda minus 2 is equal to 0, hence our lambda is equal to 2, we solve for this other one. Lambda squared minus 10 lambda plus 16 is equal to 0. So we are going to use the quadratic formula to solve. So we will have the value of lambda will be equal to, so okay, let me write it down here. If you have a quadratic equation, let's say ax squared plus bx plus c is equal to 0, then x is given by minus b plus minus the square root of b squared minus 4ac, all this divided by 2a. So this is basically quadratic formula. So that's what I'm using. So to get lambda, it will be minus 10 plus minus the square root of minus 10 squared minus 4 times 1 times 16, all this divided by 2 times 1. So what's the value of lambda? Lambda is equal to 10 plus minus the square root of 10 squared, that will give us 100. 100 minus 16 times 4. So what will that give? So 16 times 4, I hope we have that value right. 16 times 4 will basically give. So guys, you can be able to calculate that and get our values of lambda, yeah? Yes. From there, I think you guys can be able to continue. I don't have a calculator, so like going to do, this is 100. I'm trying to just do it by hand. Let me see. 2, so 4. Okay, fine. So let's just finish doing it anyway. Let me get a calculator. So that's 16 times 4. That will give me 64. 100 minus 64. That will give me 36. Root of 36. That will be 6. So here, inside the square root sign, we'll just have 6. So let me not write that. I'll just have 6 over there. Okay, so I'll just have so I'll have 6 here, all this divided by 2. So what are the values of lambda? Lambda is equal to 10 plus 6 will give 16. 16 divided by 2, that will give 8. And then 10 minus 6 will give 4. 4 divided by 2, lambda is equal to 2. And remember, we also had this other value of lambda is equal to 2. So the eigenvalues are, so our eigenvalues are lambda is equal to 2, lambda is equal to 2, and lambda is equal to 8. Those are our eigenvalues. Or, as the question asked, those are the characteristic roots. Those are the characteristic roots.